Take it away, Jeff. Jeff, you're currently muted.
Unmute. There we go. So, do you see, Jimmy? Do you see a diesel or 490 on the screen?
Yes. Yes.
Okay. So, once again, thank you for coming along. This is the second in the 3-day series on selected catalytic reduction, a pretty tightly formatted presentation with some feedback. And we'll look at those elements as we move along. There's a lot to do today, especially when I include the feedback. So our 490, our EC490 exhaust aftertreatment system is set up on a Ford 6.7 liter Power Stroke platform. This is a smaller version of what you see on the heavy duty trucks, and of course much smaller than you see in heavy equipment and heavy duty shipping. But the components are the same, and the components may have some different configurations, and we're going to look at that. So thanks for coming along. And there we go. You get some. So yesterday, I recorded a video that the sound didn't come out on. Like I say, I'm willing to hang it out there and make a mistake. So this morning I'm going to correct that mistake and show you a static picture of what my board looked like just before I started this presentation. So I always sort things into do, doing, done, and then there's a parking lot for things that, you know, I really want to look at, but I'm not going to get done. So in the done, Monday and Tuesday are in the can, right? We've got those done. Today, for those that find that hard to read, because it is a lot of writing, I'm going to discuss the audience a little bit. I'm going to hang there for a second. We have to be careful as subject matter experts, or not, or trying to present something that we were familiar with, to not leave the learner in the dust. I know we've all been to that presentation where the person doing the presentation is obviously very smart. And I've walked out of some of those and go, wow, that guy is really smart, or that lady is really smart. There's a lot of information. I was hit with a fire hose, and I'm not sure what I'm going to take away from that and use. So when we're in this situation where I'm doing a class here right now on how you might handle your students, we have to be very cautious of our learner, because we know maybe a lot and they don't know very much. And what I'm always concerned with, a shop owner came to me one time and said, you know, what I want for my students to learn, notice I almost said, what I want you to teach. I turned that phrase in, what I really need my employees to learn, or the student that's working for me, is how to make the truck go out of the bay today. And really, we need the basics of what's going on. So, man, there's so many interesting things in this DEF system, but we're going to have to target ourselves as we go through this. So today, I'm basically going to go through DEF quality, and how to test for DEF and fluid, diesel exhaust fluid quality. But one thing I had you do yesterday, those of you who attended yesterday, and thank you all who filled out that form with the questions, because now I'm going to show you those questions, and they've been anonymized. So the first question was, what's the muddiest concept for you about the SCR? So you can see I've checked off, I've gone through, I've read all of them, I've highlighted some comments. You know, I put a smiley face, had smile myself. It's all equal, buddy. I'm just a simple-minded gas guy. Well, we're all here to learn, right? So how the PCM responds to NOx and the EGR sensors inputs, man, that's a whole couple of days of class right there. So you're getting into sensor inputs and outputs when right now I really want to concentrate on the DEF fluid and the selective catalytic reduction. So as we go through this, I get a sense, to me, that, you know, perhaps we somewhat hit the mark yesterday, but there's more things to discuss. So let's move to the next page. One thing that you learned today. So when I do this with students, I do this as an anonymous handout, just like the form was. And then I always bring it back to show the other students. So I anonymize all the replies and then I post them so that they can see them. Often I would print them and give them out to the students. So what I'm looking for is, you know, a string of things that stuck, right? We threw a lot of stuff up against the wall. Maybe these things stuck. I probably need to ratchet back a little bit on my comment that the DEF injector is more like a garden hose sprayer and not a precise measured injector. Let me qualify that by saying it is not the same as a high pressure common rail fuel injector that's injecting fuel at 30,000 psi. It is a nozzle, it is an injector, it needs to be clean, and it needs to get rid of the fluid or inject that fluid at a programmable or a rate that can be correlated back to the pump. And then all those sensors are going to help regulate that, because there's going to be correlation between all the pressure and temperature sensors, and in the end, the NOx sensor. So it's important that we know that an injector can be a problem. They do crust up at the nozzle. So, but we use the data, which is beyond this class right now, to troubleshoot those. Learn some about the composition of urea. Love the diagram section. Yeah, that's kind of fun. I like to draw on the screen on an image to show where my mind is going, so that I can demonstrate this to the student, my learning as I go through. Well, I'm not so sure about fantastic PowerPoints, but thank you. Placement of the depth, lowers temperature. So there's a lot of good comments there, and I appreciate that. So the last page, tell me one thing that you would have liked to see from the session was not demonstrated. So I'm not picking on whoever put the all good there, but I really want to challenge you to think about what really would help your learning. That's what this question is about. What's going to speak to you about your learning? Because I'm using this question and answer method because I don't see your faces. We're going to maybe ask for hands in a little bit, and we can discuss further things. But when we're in the mix of this, I don't know if I'm hitting it or not. So if I ask questions after the first class, then I can get myself back on track for the second class, and so on and so forth. I would normally only do this in the classroom in a face-to-face situation. At the middle portion of a topic, you know, say I've got a week-long class on electrical, I might do 2 or 3 of these. Not every day. People get tired of filling out forms. I know I sure do when somebody wants me to rate something, and you know, every time I go somewhere, they want a rating on a hotel. So great questions, keep them coming. So let's review a little bit as we move into where we're going. Again, our atmosphere, we have this big component of N2, nitrogen, 78%. There's a lot of things about Earth that are good to us, and we need that nitrogen, but it's problematic after we run it through a combustion process. So let's review again. We're going to talk about the DEF fluid and the selective catalytic reduction unit as we move along. Let's identify a couple of things here. One, the arrows. We need to make sure that we follow the arrow flow, because the next component in the system is where we make the turn on our EC490 board, where we go to the bottom half. And the flow is going to be in the other direction. And that's only just to follow the realism of the board, so that we're all operating in the same direction. So we want to be sure to pay attention to the arrows. Coming into the decomposition or spiral mixing chamber, we've got carbon dioxide, oxides of nitrogen, H2 water, and particulate matter. It's kind of funny when I ask questions. I made mistakes on the first couple times that I did this. I asked about what gases are coming through. Well, particulate matter really isn't a gas, it's a solid, and it has to be dealt with in another way. So I often will call it constituent components or whatever, what comes out at the other end of this. So the chemistry of the urea, I'm not going to get very much in depth to that. Does the student need to know the exact composition, other than it's a mix of urea and water at a certain percentage, that needs to be accurate? That's something we're going to talk about here in a little bit. Diesel exhaust fluid, here it is. You'll see that I'll often use Creative Commons because of the share alike license. So with the Creative Commons license, I can go in and share, copy and share, and give attribution to what's been done. And I've heard the old saw for 20 years that, anybody can write anything they want in Wikipedia. And yes, this is true. But it's pretty closely watched and edited. Some of these pages that are listed, I see that they've been edited in the past few days. So, go through and check the sources. Some of these explanations that I put up have 100 different attributions of research. So, but what's really important to us is that the diesel exhaust fluid has a standard. That standard is very tight. The standard is called out in ISO documentation. You're welcome to click on the resource here at the bottom of the page here. You can just click on this, and that'll take you right to the page where I copied this information. But be sure to give credit for it. That's the right thing to do. So water and urea. Here's the makeup of urea. So to not get too deep into this, carbon, oxygen, nitrogen, and hydrogen in various organic bonds and all that other stuff. I love, actually I love chemistry, but we're not going to go there today because I'm not that great at it, but it's also a great thing that I learn every time. So urea, and then of course we know this one, right? This is just common water. I would guess that it's deionized or some very pure form of water. So let's think about this fluid that's 32.5% urea and the rest is water. Do you think this is corrosive? Yeah, it's pretty darn corrosive. We've got metal parts, metal injectors. We have hydraulic valves to control and solenoids to control DEF fluid flow. There's various clean out cycles. There's been many changes in control systems. The early heavy duty truck ones, they used the compressed air from the air compressor to help atomize the DEF fluid. And for any of you that are involved with heavy duty trucks, you know that air systems are often not the cleanest. So the contamination issues have come up. And this is a lot of the problem that the feedback that I get from shops is, yeah, it was just contaminated DEF. We did all this, we changed all these sensors and whatever, but it had the bad fluid in it, right? So you got to be cautious of that. Let me let this sink in a second. If you read the first sentence, you'll see that I have gone into the description of what urine is. And nothing sets me off worse than a group of truck drivers standing around talking about that they're going to pee in their DEF tank, or that they're going to add some sort of other fluid into the DEF tank. Man, this is poison. Truck driver stories, you know, you can't have contaminated DEF. It's just not going to work. So how do we test? And right now I'd like to say that this is a copy from a screen capture from the OTC Tools website. Right down there at the bottom, you see where I sourced that. I want to be sure to give credit to Bosch. This is not me, but I think if, you know, I sell a couple tools, they'll be all right with it. So these refractometers, you've used them before long ago, checking battery electrolyte, coolant, and other substances. So let me go through a little bit about this refractometer. It needs to have a null point or a calibration point. So there is what it looks like through the screen with water. Also on this is called the reticle. Also on the reticle is 32.5% line. So it's right there. Of course, it's targeted with AdBlue urea, which is just a trade name. Actually, should be a registered trademark, I suppose. So here, two different pictures, the scale without any fluid in it or liquid in it, and then the scale with the liquid in it. It's a pretty tight window for this fluid to work. So we want to be sure that the student learns how to test DEF fluid, because we need to verify that early on in our troubleshooting analysis with a system that's not functioning. So one of the first things, so this is why this is on the list, because shop owners had come to me and said, you know, we've got the specific gravity tester. It'd be great if the student knew how to use it and knew how to read it. There's also this high-speed, low-drag model here, electronic one, where you put the droplet and it measures it electronically. I've seen these in classes. I haven't used them extensively personally. I went to, some years ago, I went to a Freightliner factory class in Portland, and the way we tested DEF fluid, and I don't have a bunch of beakers here and any DEF fluid, but we had a series of like 6 beakers filled with different fluids. Water, windshield washer fluid, DEF. You know, nobody went out to the farm and collected anything from the cows, but you know, there were some contaminated looking fluids. So one of the first things, of course, is like any fluid is a visual. You know, what does it look like? So is it clean? Does it have dirt in it? Do truck drivers and equipment operators always wipe down their fuel tank area, the lid of the fuel tank? Well, no. And, you know, in the old days, you know, I remember Caterpillar fuel caps say, buy clean fuel, keep it clean. But those were low pressure fuel systems and not dealing with 30,000 PSI. You know, they had 10 micron filters on the fuel system, or maybe even 30 micron filters on the fuel system. Well, now we're filtering down into the below 10 microns, below 5 microns. Fuel systems we're dealing with pressures of 30,000 PSI. The tolerances are exceedingly close. And now we're in dealing with the DEF fluid and the injector and the valving. Guess what? Tolerances are exceedingly close. Then we throw in a corrosive liquid. So, you know, what could go wrong? Well, a lot can go wrong. This is a will fitter, I would call it. You can take a look at the different things that are on there. This is supposed to be able to test 4 different fluids with the water line and electrolyte and urea and windshield washer fluid. And that's important in some places. But you can buy these. There's the link to where I copied it right down at the bottom. So take a minute and take a look at this slide. We're a Cummins OEM because we manufacture engine benches and we buy factory from Cummins, and they have allowed us to use these slides. You'll see the copyright at the lower right of the screen. But take a second and read through that. I'm going to pause. So one thing I do when I put slides up is I don't read them because the students often can read them faster than I can. And personally, it's one of those things that distracts me in presentations where I'm trying to read the screen. Somebody's trying to read the screen for me. The two of those meet in a head-on collision in my brain, and it doesn't work. So that's why I don't put a lot of words on the screen usually, but sometimes you've got to have a fair amount on there. So this one is set up so that the flow is going to be from the left of your screen to the right of your screen. Okay, so let's get back in our system. So moving from the left of the screen to the right of the screen, those gases, you can see them all there, I've read them off before, are going to be mixed within the swirl chamber or the decomposition tube, where some of the water is evaporated out of, and this is my understanding, right? I'm parroting a little bit because it's the chemistry that maybe goes a little deeper, but is, you know, what exactly does the student need to have? Well, he needs to not have misinformation. So anyway, we move from left to right through there, and these are the gases that come out. Well, next, I put this slide back in here because we got to remember that we've come from here, the injector, decomposition tube. Now we're going to change directions on the slide. So the next slide is going to show that the exhaust is moving from right to left. This is only to make the turn. It's not something special. And here we've made the turn. So these are the same, I'm going to call them constituent gases, and one particulate are going to travel into the selected catalytic reduction unit, which is a pass-through. So this operates like a diesel oxidation catalyst is a pass-through as well, where the components move over the ceramic that's been coated with the metals. And you can research that a little further, but essentially those 6 components are going to come in, and because of the pass-through nature, this is not a filter like a diesel particulate filter is, where the ends of it's not a pass-through. Each one of the passages in a diesel particulate filter has to move through a porous ceramic. Well, this is moving through actual tubes within the substrate. So that chemical reaction is going to happen. The electrons are going to, and elements are going to trade places. It's a reductant reaction, and the output is CO2, nitrogen, water, particulate matter. Could somebody mute, please? So there we go. Someone mute. So the gases are going to roll through, and this is what's going to happen. You can refer back to this slide later, but I'll give you a chance to read that. So as we move along through the system, now we've got the diesel particulate filter. Now, the diesel particulate filter may be located in a different position. This may be in front of the selective catalytic reduction unit. And one of the questions was why? Why is it in this order? And, I've heard a number of explanations. Room under the vehicle being one of them, not wanting to have that hot component further up, maybe under the fuel tank. But I think they figured that because the selective catalytic reduction unit is a pass-through, that the soot's going to move on through. And it appears to operate that way.
Jeff, Phil has
yes?
his hand raised.
Pardon?
Phil Fournier has his hand raised.
Okay, can I move through and then we'll
circle back.
We'll circle back, Phil.
Okay.
Thank you. Because we're gonna run out of time here in a second. So the diesel particulate filter is going to catch the particulate matter. All the rest is going to go right on through, right? So this, if you would view the diesel particulate filter as an air filter that gets plugged over time, and then we run a regeneration cycle to turn the soot into ash. And eventually, over miles and miles and miles, the ash is going to build up, and the diesel particulate filter either needs to be cleaned or replaced. So here we've gone through the whole system and hopefully shown a bit of the interaction. I placed a great deal of importance on DEF fluid testing to verify that it is 32.5% mixture of urea and water. So accuracy is important. And I'm going to stop sharing my screen. So now would be a great time for, oh, before we do that, Tim, could you push out the questionnaire?
Done.
Okay. And I would encourage you, please, to take a minute to go through that. There's a couple of simple questions. They're immensely important in the planning of what we do, or what I do anyway. I know I'm not, we're all different, right? We all have different presentation styles. But I hope my style, in my view, reaches my student better. And my student, if you're an instructor, my students would be your students. And hopefully this helps you present that. So what'd you have?
Phil's right there. He just
Phil?
jumped on. So Phil,
Yep.
go ahead and unmute and fire away.
Thank you, Jimmy. Jeff,
Yes.
I know, I understand, forgive me, because my chemistry is way outdated, like about 45 years.
Yeah,
But
well, me too.
what I remember is that the reason we call the SCR a reduction is because we're reducing it by taking the oxygen off the nitrogen. Okay, so far?
Yep, that's my,
okay, but,
and then it's going to tie up with the water.
Okay, so what I'm trying to put together here is really trying to understand those temperature sensors, because obviously they're there for some reason, even though we haven't quite figured it out. But the process of pulling the oxygen off and then it combines with the hydrogen, aren't we oxidizing the hydrogen and therefore creating some heat? Or is my chemistry too weak to handle the job? Because if we end up with water, we got to combine the hydrogen with the oxygen again.
See, there's the thing, Phil. I don't know. I could learn it. You know, I could go out and as I need, I learn on demand fairly quickly when I target. But the caution that I gave in the beginning about fire hosing the students. It's great. I think it's great if the student wants to learn that. And if we've got time in class, that's going to be a teachable moment. Yes, absolutely. I've also found that at the school setting or college setting, go see the chemistry instructor. One, to get ideas, but two, to show them that diesel does involve some chemistry, right? There's some things that have to happen. And a lot of times they can shed some light, your chemistry instructor, and then also get them interested. Maybe they'll put that component in a class. If they have a class full of diesel students, would it be great if their chemistry section was targeted a little bit around combustion principles? We brought a little Haywood in. We talked about those things. It'd be great. But first things first, the shop owner doesn't expect that the student's going to be able to lay out the chemical diagram and spend all in writing it and moving all the atoms around in the right spot. They want to fix the thing so it can get down the road. So
right. And I appreciate that. The only reason I would like to know is because I'm trying to understand temperature sensor 3 and 4 and what the computer does with them. That's what bothers me, I don't know.